What's up, guys? Michael Tomek here from South Coast Welding Academy. We're back with another video with a TIG root pass from my good friend Travis here. He's going to tell you how to back feed by looking through the gap. I'm going to go ahead and hand it over to him now.
Thank you, Mike. What I'm going to be doing here is a 12-inch, a 375 wall, but I'm going to be using a welding technique that was taught to me in about 2010 by my superintendent at Mike Ho. And this particular technique you had to use at the pipe fabrication shop, otherwise you did not TIG weld there. And basically what it's going to be is I'm going to have the fill metal up top here with the tack here. I'm going to be looking through the gap right here, and I'm going to be TIG welding down here, feeding it, and TIG welding that way. Left hand side, I'm going to go over here and I'm going to do the very same thing with the right hand side. Okay, so what I have here, I have a tack at 12 o'clock, a tack at 9 o'clock, a tack at 7 o'clock. I have the filament metal, the tack is on this side, I'm welding this side, the filament metal goes against that side. I'm going to come over here, this is how I'm going to feed the filament metal. I'm going to have my hand resting on the pipe here. And I'm going to have my TIG torch down here. So essentially all I'm moving is from bevel tip to bevel tip, and I'm just looking through the gap here. But essentially with this particular technique, it's going to be using a continuous feed technique. And I have my filament metal on the leading edge. It is continuously feeding into the weld puddle, and I have the TIG torch in the middle of the weld puddle, and I'm just kind of pushing the weld puddle around. So the weld puddle, all the heat of the weld puddle is just breaking down the bevel tips and breaking down the filament metal, which is being melted continuously. I'm going to weld from about 6 o'clock all the way up to about 2 o'clock or 2:30, or if the filament metal runs out, once I'm done that, I'm going to run to the other side of the pipe here. I'm going to reach over, and now I'm going to pull the root bead, the weld puddle, up towards me, because it is easier to pull the weld puddle up towards me to about 12 o'clock than it is to stand on this side of the pipe and try and reach over and weld up to here. But also, when I weld from here to here, this tack will be moved out, and I'll be back feeding from around here. When I weld up to 12 o'clock, this whole half side will be done. I'll now switch over to this side here. This tack will be out, I'll feather that start. I'll cut this tack out at 9 o'clock. I'll cut the 7 o'clock tack out. I'll feather the start. Now I'll be doing the same thing on this hand side. So I'll be welding up to about 2 o'clock. Then when I'll come over to this side, I'll thin out the start, clean up the top, and then I'll close it. All right, now this 12-inch 375 ball, I have it on a welding positioner, so I'm going to rotate the pipe and I'm going to show the different, I'm going to talk about the weld basically. This is the bottom of the weld, this is the bottom tie-in. Now this is going up the left-hand side. This is the side I started first. So we're going to see the bottom, I'm going to rotate it very, very slowly. Now this was with a 532 filament metal. The 532 deposits more metal. It's easier to use a 532 on larger diameter piping, say 12-inch, 14-inch, because you don't have to feed as much metal. We are coming up to where I used a 1/8 filament metal, and I had that marked out. So about up to maybe about somewhere around here, I believe right here, it switches to a 1/8. Reason why I switched is because I did not want a heavy buildup on the top, because as you know, it has more buildup with 532 filament metal at the bottom, which is relatively helpful. But 1/8 keeps a more uniform bead, and it's also less deposition in comparison to the 532. This is left-hand side, we're coming up to the tie-in. Also, you can tell by a little bit of the smoke here. We have the tie-in there. Tie-in was done with the right-hand side, which I'll be showing here. We now have the right-hand side. Right here, about 2 inches away from where I tied in, is where I ran out of filament metal, and I had Mike pass me more filament metal. This is right-hand side. This is done with a 1/8 filament metal to avoid buildup. I wanted to have the weld bead relatively uniform, the root pass uniform. This is all 1/8 up here. This right here is 532. This is the lower bottom portion of the pipe. This is all 532, and this was done with the right-hand side. And we're coming back to the pipe. I believe this is silicate or silicon. Cannot remember the differentiation between the two. It just covers the weld bead. Now I was using 70S-2 and 70S-6 for the 1/8 and 532 beads. We're back at the bottom. This is the tie-in. This side is right-hand side. This side is the left-hand side. And this is the root pass on this pipe, done with 532 and 1/8 filament metal. With this particular technique, many years ago, Mike Ho, who was my superintendent in a pipe fabrication shop I worked at, he is the one who taught me this, and I just want to say thank you to Mike, because this particular technique really greatly improved my welding ability and my TIG welding ability, and it really opened a lot of doors for me. So I just want to say thank you, and you can follow me on Instagram at FieldRes. Thank you.